Imagine a spaceship that can heal itself after being hit by a tiny meteoroid, sealing a hole in the vacuum of space like your skin heals a cut. Now imagine a spacesuit thinner than paper, but stronger than steel. Or a swarm of microscopic robots patrolling an astronaut's body, ready to spot a disease before they even feel sick. This isn't science fiction. This is what's being built right now. And it's all possible because of technology so small you can't even see it. We are on the edge of a brand new space age, one that's not being driven by bigger rockets, but by the smallest things imaginable. The question isn't if this will change our journey to the stars, but how much. Is nanotechnology completely revolutionizing space exploration? Before we get to the revolution, you have to understand why the old way was so brutal. For more than 50 years, going to space has been about using brute force to survive an environment that wants to destroy you. Every mission has been a battle against three massive challenges. First, there's the weight problem. Every single gram you want to launch into space costs thousands of dollars in rocket fuel. To beat Earth's gravity, we build these insanely huge rockets that are basically just giant fuel tanks, all to get a tiny payload into orbit. This insane cost has always held us back. We've had to choose. Do we pack more science gear, more fuel to go farther, or more shielding for the crew? For decades, engineers have been stuck trying to shave a few kilograms off their designs without making them too weak to survive a launch. The second challenge is that space itself is just incredibly hostile. The vacuum of space isn't empty, it's a cosmic shooting gallery. Tiny particles, some smaller than a grain of sand, are flying around at over 70,000 miles per hour. A hit from one of these can be catastrophic, punching right through a spacecraft's hull. Then you've got the insane temperature swings. In orbit, a satellite can go from scorching hot to freezing cold in minutes, which stresses and cracks materials. And on top of all that is the invisible threat, radiation. Without Earth's magnetic field, astronauts and electronics get blasted by cosmic rays that can break down equipment and cause serious health problems. And that leads to the biggest challenge of all, keeping people alive. Our bodies are just not built for space. In zero gravity, muscles waste away and bones get brittle. A long trip, like one to Mars, would expose astronauts to dangerous levels of radiation. Their life support has to be perfect, recycling every last drop of water and every molecule of air. We need ways to monitor their health constantly, because you can't just go to the emergency room when you're millions of miles from home. For decades, these problems set the limits for humanity. To go farther or stay longer, we couldn't just keep building the same way. We needed something completely new. The answer wasn't to build bigger, but to think smaller. Impossibly small. So what is this game-changing tech? Nanotechnology means building things on the atomic and molecular scale. For perspective, a single sheet of paper is about 75,000 nanometers thick. We're talking about building materials atom by atom to give them unbelievable new properties. And this is where we get the breakthroughs we desperately need. Let's go back to that first killer problem. Weight. The solution from the nano world sounds like it's straight out of a comic book. Carbon nanotubes and graphene. Carbon nanotubes are tiny tubes of carbon atoms that are 100 times stronger than steel but weigh almost nothing. Then there's graphene, which is a single sheet of carbon atoms that's super lightweight, nearly transparent, and an incredible conductor of heat and electricity. And this isn't just a science experiment. NASA is already using these materials to build what they call super lightweight aerospace composites. By mixing carbon nanotubes into traditional materials, they can build parts of a spaceship that are way lighter but just as strong. This is a total game changer. A lighter ship needs less fuel, which means launches are cheaper. And that saved weight can be used for more science gear, extra fuel to explore the outer solar system, or better shielding for the crew. NASA thinks this could cut a vehicle's mass by up to 50%, completely flipping the economics of space travel. But what about surviving that cosmic shooting gallery? Nanotechnology gives us a new type of armor. Instead of thick metal, we can apply super thin nano coatings to a ship's hull. These coatings can be designed to resist erosion and block harmful radiation. And this leads to one of the most mind-blowing ideas: self-healing spaceships. Imagine a micrometeoroid hits a ship on its way to Mars. Instead of a disaster, the impact breaks open millions of tiny capsules embedded in the hull. A liquid healing agent floods the crack, mixes with a catalyst, and instantly hardens, sealing the hole. Researchers are already testing these materials on the International Space Station. This tech turns a fragile machine into something that's almost alive, able to heal itself and survive deep space on its own. Building a tough spaceship is one thing, but keeping the human body safe inside is a whole different ballgame. On long missions, radiation is one of the biggest dangers to astronauts. The old solution was just thick layers of aluminum, but that adds a ton of weight. Our old enemy. Nanotechnology has a much smarter solution. Materials like boron nitride nanotubes are being made specifically to block radiation. They are amazing at absorbing or scattering those dangerous cosmic rays. And because they're so light and strong, they can be woven right into the walls of the ship and even into the fabric of a spacesuit. You get top-tier protection without the weight. Spacesuits are also getting nanocoatings to improve insulation and make them tougher. But protection isn't just about blocking things. It's about knowing what's happening to an astronaut's body. This is where nanomedicine comes in. Imagine tiny nanosensors that can be injected or worn in a patch. These sensors could constantly track an astronaut's vitals, their radiation dose, and even detect the chemical signs of stress or illness before they show any symptoms. It's like having a full medical lab, shrunk to an invisible scale working 24/7. This is absolutely critical for a trip to Mars. The revolution even extends to the air they breathe and the water they drink. NASA's life support systems already use nano-based filters to purify and recycle water with incredible efficiency. Advanced nanofilters can remove the tiniest contaminants, making sure astronauts have clean air and water. This not only keeps them healthy, but also means they don't have to launch as many supplies from Earth, which, you guessed it, saves weight. We've seen how nanotech can build tougher spaceships and protect the people inside. But how do we power these next-gen missions? Out in the darkness of space, energy is everything. For years, we've depended on solar panels, but they have big limits. They're heavy, they get damaged by radiation, and they become useless the farther you get from the sun. Once again, nanotechnology is giving us a massive upgrade. Scientists are creating solar cells using quantum dots, tiny semiconductor particles that can capture way more light and turn it into electricity more efficiently. This means we can get more power from smaller, lighter solar panels. And for the trips where sunlight is weak, like missions to the outer planets, nanotechnology is improving thermoelectric generators. These devices turn waste heat directly into electricity, and new nanostructured materials are way better at doing it, providing a super reliable power source for exploring the darkest parts of our solar system. This revolution in materials and power unlocks the next big step: smarter robots. Mars rovers like Perseverance are already incredible, but their abilities are being supercharged by nanotechnology. Their parts are made of advanced lightweight materials, and their science tools use nanoscale sensors to analyze Mars with stunning precision. But the real game changer is combining nanotechnology with AI. Future rovers will have even more advanced nanosensors, letting them feel and smell their environment in ways we can only dream of. An AI could process all that data instantly, allowing a rover to spot an interesting rock, analyze what it's made of, and decide to investigate on its own, all without waiting for instructions from Earth. This level of autonomy is everything. The time delay makes controlling a rover on Mars incredibly slow. By giving robots the power to think for themselves, thanks to data from nanosensors, we can speed up the pace of discovery like never before. Of course, this future isn't here just yet. One of the biggest hurdles is simply making enough of this stuff. It's one thing to make a small amount of perfect carbon nanotubes in a lab. It's another to manufacture tons of it reliably to build an entire spaceship. We're getting better at it, but making it cheap and consistent is still a huge challenge. There are also serious safety questions. As we start putting nanosensors inside of astronauts, we have to be absolutely sure they're safe for the long term. But even with these hurdles, the momentum is undeniable. Programs like NASA's Innovative Advanced Concepts are pouring money into these futuristic ideas, from new kinds of rockets to building habitats on the moon with these advanced materials. So, is nanotechnology revolutionizing space exploration? The answer is a massive yes. This isn't just a small improvement. It's a complete rewrite of the rules. We're solving the biggest problems in space: weight, radiation, power, and human survival, with technology engineered atom by atom. Lighter and stronger materials are making space travel cheaper and our missions bigger. Self-healing ships and better radiation shielding are making space safer for our astronauts. Hyper-efficient power systems are fueling our journey into the void, and intelligent, nano-powered robots are becoming our partners in discovery. We're about to enter an era where the biggest leaps in exploring our universe will be powered by the smallest things we can imagine. The real space age, the one that takes us back to the moon, to Mars and beyond, is going to be the nano age. We've seen how nanotech can build tougher spaceships and protect the people inside. What do you think is the most exciting part of all this? The self-healing spaceships, the tiny medical robots, or something else? Let me know what you think down in the comments. Now's the perfect time to subscribe and ring that notification bell. We explore the absolute edge of technology, and you don't want to miss what's coming next. Thanks for watching.